Anti-gravity is an idea of creating a place or object that is free from the force of gravity. It does not refer to the lack of weight under gravity experienced in free fall or orbit, or to balancing the force of gravity with some other force, such as electromagnetism or aerodynamic lift. Anti-gravity is a recurring concept in science fiction, particularly in the context of spacecraft propulsion. An early example is the gravity-blocking substance, gravity, in H.G. Wells' The First Men in the Moon. In Newton's law of universal gravitation, gravity was an external force transmitted by unknown means. In the 20th century, Newton's model was replaced by general relativity, where gravity is not a force but the result of the geometry of space-time. Under general relativity, anti-gravity is impossible except under contrived circumstances. Quantum physicists have postulated the existence of gravitons, a set of massless elementary particles that transmit the force, and the possibility of creating or destroying these is unclear. Anti-gravity is often used colloquially to refer to devices that look as if they reverse gravity even though they operate through other means, such as lifters, which fly in the air by moving air with electromagnetic fields. Hypothetical solutions. Gravity shields. In 1948, successful businessman Roger Babson formed the Gravity Research Foundation to study ways to reduce the effects of gravity. Their efforts were initially somewhat crankish, but they held occasional conferences that drew such people as Clarence Birdseye, known for his frozen food products, and Igor Sikorsky, inventor of the helicopter. Over time, the foundation turned its attention away from trying to control gravity, to simply better understanding it. The foundation nearly disappeared after Babson's death in 1967. However, it continues to run an essay award, offering prizes of up to $5,000. As of 2013, it is still administered out of Wellesley, Massachusetts, by George Rideout, Jr., son of the foundation's original director. Winners include California astrophysicist George F. Smoot, who later won the 2006 Nobel Prize in Physics. General relativity research. In the 1950s, general relativity was introduced in the 1910s, but development of the theory was greatly slowed by a lack of suitable mathematical tools. Although it appeared that anti-gravity was outlawed under general relativity, there were a number of efforts to study potential solutions that allowed anti-gravity type effects. It is claimed the U.S. Air Force also ran a study effort throughout the 1950s and into the 1960s. Former Lieutenant Colonel Ansel Talbot wrote two series of newspaper articles claiming that most of the major aviation firms had started gravity-controlled propulsion research in the 1950s. However, there is little outside confirmation of these stories, and since they take place in the midst of the policy by press release era, it is not clear how much weight these stories should be given. It is known that there were serious efforts underway at the Glenn L. Martin Company, who formed the Research Institute for Advanced Study. Major newspapers announced the contract that had been made between theoretical physicist Buck Hardheim and the Glenn L. Martin Company. Another effort in the private sector to master an understanding of gravitation was the creation of the Institute for Field Physics, University of North Carolina at Chapel Hill in 1956, by Gravity Research Foundation trustee Agnew H. Barnson. Military support for anti-gravity projects was terminated by the Mansfield Amendment of 1973, which restricted Department of Defense spending to only the areas of scientific research with explicit military applications. The Mansfield Amendment was passed specifically to end long-running projects that had little to show for their efforts. Under general relativity, gravity is the result of following spatial geometry caused by local mass energy. This theory holds that it is the altered shape of space, deformed by massive objects, that causes gravity, which is actually a property of deformed space rather than being a true force. Although the equations cannot normally produce a negative geometry, it is possible to do so by using negative mass. The same equations do not, of themselves, rule out the existence of negative mass. Both general relativity and Newtonian gravity appear to predict that negative mass would produce a repulsive gravitational field. In particular, Sir Hermann Bondi proposed in 1957 that negative gravitational mass, combined with negative inertial mass, would comply with the strong equivalence principle of general relativity theory and the Newtonian laws of conservation of linear momentum and energy. Bondi's proof yielded singularity-free solutions for the relativity equations. In July 1988, Robert L. Forward presented a paper at the AIAA, ASME, SAE, ASEE 24th Joint Propulsion Conference that proposed a Bondi negative gravitational mass propulsion system. Bondi pointed out that a negative mass will fall toward normal matter, since although the gravitational force is repulsive, the negative mass responds by accelerating in the opposite of the direction of the force. Normal mass, on the other hand, will fall away from the negative matter. He noted that two identical masses, one positive and one negative, placed near each other will therefore self-accelerate in the direction of the line between them, with the negative mass chasing after the positive mass. Notice that, because the negative mass acquires negative kinetic energy, the total energy of the accelerating masses remains at zero. Forward pointed out that the self-acceleration effect is due to the negative inertial mass, and could be seen induced without the gravitational forces between the particles. The standard model of particle physics, which describes all presently known forms of matter, does not include negative mass. Although cosmological dark matter may consist of particles outside the standard model whose nature is unknown, their mass is ostensibly known, since they were postulated from their gravitational effects on surrounding objects, which implies their mass is positive. The proposed cosmological dark energy, on the other hand, is more complicated, since according to general relativity the effects of both its energy density and its negative pressure contribute to its gravitational effect. Fifth force under the general relativity, any form of energy couples with spacetime to create the geometries that cause gravity. A long-standing question was whether or not these same equations applied to antimatter. The issue was considered solved in 1960 with the development of CPT symmetry, which demonstrated that antimatter follows the same laws of physics as normal matter, and therefore has positive energy content and also causes gravity like normal matter. For much of the last quarter of the 20th century, the physics community was involved in attempts to produce a unified field theory, a single physical theory that explains the four fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. Scientists have made progress in unifying the three quantum forces, but gravity has remained a problem in every attempt. This has not stopped any number of such attempts from being made, however. Generally these attempts try to quantize gravity by positing a particle, the graviton, that carried gravity in the same way that photons carry electromagnetism. Simple attempts along this direction all failed, however, leading to more complex examples that attempted to account for these problems. Two of these, supersymmetry and the relativity-related supergravity, both required the existence of an extremely weak fifth force carried by a graviphoton, which coupled together several loose ends in quantum field theory in an organized manner. As a side effect, both theories also all but required that antimatter be affected by this fifth force in a way similar to antigravity, dictating repulsion away from mass. Several experiments were carried out in the 1990s to measure this effect, but none yielded positive results. In 2013, CERN looked for an anti-gravity effect in an experiment designed to study the energy levels within antihydrogen. The anti-gravity measurement was just an interesting sideshow, and was inconclusive. General relativistic warp drives. There are solutions of the field equations of general relativity which describe warp drives, and stable, traversable wormholes. This by itself is not significant, since any spacetime geometry is a solution of the field equations for some configuration of the stress-energy tensor field. General relativity does not constrain the geometry of spacetime unless outside constraints are placed on the stress-energy tensor. Warp drive and traversable wormhole geometries are well behaved in most areas, but require regions of exotic matter, thus they are excluded as solutions if the stress-energy tensor is limited to known forms of matter. Dark matter and dark energy are not understood enough at this present time to make general statements regarding their applicability to a warp drive. Breakthrough propulsion physics program. During the close of the 20th century, NASA provided funding for the Breakthrough Propulsion Physics program from 1996 through 2002. This program studied a number of far-out designs for space propulsion that were not receiving funding through normal university or commercial channels. Anti-gravity-like concepts were investigated under the name of diametric drive. The work of the BPP program continues in the independent, non-NASA affiliated Tau Zero Foundation. Empirical claims and commercial efforts. There have been a number of attempts to build anti-gravity devices, and a small number of reports of anti-gravity-like effects in the scientific literature. None of the examples that follow are accepted as reproducible examples of anti-gravity. Gyroscopic devices. Gyroscopes produce a force when twisted that operates out of plane, and can appear to lift themselves against gravity. Although this force is well understood to be illusory, even under Newtonian models, it has nevertheless generated numerous claims of anti-gravity devices and any number of patented devices. None of these devices have ever been demonstrated to work under controlled conditions, and have often become the subject of conspiracy theories as a result. A famous example is that of Professor Eric Laithwaite of Imperial College, London, in the 1974 address to the Royal Institution. Another, rotating device, example is shown in a series of patents granted to Henry Wallace between 1968 and 1974. His devices consist of rapidly spinning discs of brass, a material made up largely of elements with a total half-integer nuclear spin. He claimed that, by rapidly rotating a disk of such material, the nuclear spin became aligned, and as a result created a gravitomagnetic field in a fashion similar to the magnetic field created by the Barnett effect. No independent testing or public demonstration of these devices is known. In 1989, it was reported that a weight decreases along the axis of a right-spinning gyroscope. A test of this claim a year later yielded null results. A recommendation was made to conduct further tests at a 1999 AIP conference. Thomas Townsend Brown's Gravitator. In 1921, while still in high school, Thomas Townsend Brown found that a high-voltage kilage tube seemed to change mass depending on its orientation on a balance scale. Through the 1920s, Brown developed this into devices that combined high voltages with materials with high dielectric constants. He called such a device a gravitator. Braun made the claim to observers and in the media that his experiments were showing anti-gravity effects. Brown would continue his work and produced a series of high-voltage devices in the following years in attempts to sell his ideas to aircraft companies and the military. He coined the names Biefeld-Brown effect and electrogravitics in conjunction with his devices. Brown tested his asymmetrical capacitor devices in a vacuum. supposedly showing it was not a more down-to-earth electro-hydrodynamic effect generated by high-voltage ion flow in air. Electrogravitics is a popular topic in ufology, anti-gravity, free energy, with government conspiracy theorists and related websites, in books and publications, with claims that the technology became highly classified in the early 1960s and that it is used to power UFOs and the B-2 bomber. There is also research and videos on the internet purported to show lifter-style capacitor devices working in a vacuum, therefore not receiving propulsion from ion drift or ion wind being generated in air. Follow-up studies on Brown's work and other claims have been conducted by R.L. Talley in a 1990 U.S. Air Force study, NASA scientist Jonathan Campbell in a 2003 experiment, and Martin Tajmar in a 2004 paper. They have found that no thrust could be observed in a vacuum and that Brown's and other ion-lifter devices produce thrust along their axis regardless of the direction of gravity, consistent with electrohydrodynamic effects. Gravito-electric coupling. In 1992, the Russian researcher Eugene Podkletnov claimed to have discovered, whilst experimenting with superconductors, that a fast-rotating superconductor reduces the gravitational effect. Many studies have attempted to reproduce Podkletnov's experiment, always to negative results. Ning Li and Douglas Torr, of the University of Alabama in Huntsville, proposed how a time-dependent magnetic field could cause the spins of the lattice ions in a superconductor to generate detectable gravitomagnetic and gravitoelectric fields in a series of papers published between 1991 and 1993. In 1999, Li and her team appeared in Popular Mechanics, claiming to have constructed a working prototype to generate what she described as AC gravity. No further evidence of this prototype has been offered. Douglas Torr and Timur Dutta were involved in the development of a gravity generator at the University of South Carolina, according to a leaked document from the Office of Technology Transfer at the University of South Carolina and confirmed to Wired reporter Charles Platt in 1998. The device would create a force beam in any desired direction and that the university planned to patent and license this device. No further information about this university research project or the gravity generator device was ever made public. In fiction, Ride's Despicable Me, Minion Mayhem has an anti-gravity recycling room. Video games Little Big Planet 2 features a device called the Anti-Gravity Tweaker. Mario Kart 8 uses anti-gravity gameplay for go-kart racing. The Wipeout video game series uses anti-gravity physics for racing. Books. Spin Lizzy is an anti-gravity drive in the science fiction novels of James Blish. Goddard Award. The Institute for Gravity Research of the Goddard Scientific Foundation has tried to reproduce many of the different experiments which claim any anti-gravity effects. All attempts by this group to observe an anti-gravity effect by reproducing past experiments have been unsuccessful thus far. The foundation has offered a reward of €1 million for a reproducible anti-gravity experiment.